Good evening, for the first time in 1983. This is going to be the year of La Palma, the great new observatory being set up in the Canary Islands, and I'll say more about that in a moment. Also, we have our latest newsletter ready, and I'll give you the address to send for it at the end of the program. But you know, looking back at 1982, it wasn't without its moments, and in particular, there was the recovery of Halley's Comet, seen for the first time since it disappeared from sight in 1911. And there is the actual discovery photograph, and you can see the comet as a tiny blur inside the circle that's been put on the picture. It's dead on course, it's coming in toward the sun, and of course it'll get brighter as it draws in. But I'm afraid it won't be visible with the naked eye much before the end of 1985, and then it will remain so until the spring of 1986. I can't pretend this is going to be the best return of Halley's Comet. It probably won't be as bright as it was last time it came round in 1910, because it so happens that the Earth and the comet are not quite in the right places at the right time. But at least it's there, and it is an old friend. I've been asked, you know, whether comets can ever collide with the sun. And the answer is yes. Look at this impression by Paul Doherty. There we see a comet streaking toward the sun. It'll hit it at a speed of something like 350 miles per second. And of course it can't survive. Now that's an impression, but we know it happens because no less than 3 comets have now been caught in the act. And the first of these was detected in 1981 from a picture taken by a satellite in 1979. The satellite was actually photographing the sun, and the sun had been surrounded by a dark screen to cut out the brilliance. But when the picture was examined, there was the comet going straight in. And another picture, taken some hours later, showed the comet as it actually went round the sun, and the head never reappeared at all. So undoubtedly, that comet was either engulfed or disrupted, and it no longer exists. Well, I can promise you that Halley's Comet won't fall into the sun, but it is true that comets on the cosmical scale are fairly short-lived things, because they're made up chiefly of ices and dust and thin gas, and every time a comet comes close to the sun, it's heated, and some of the ices in its nucleus evaporate, and the comet loses that amount of mass. And certainly that's happening to the Halley's Comet. But of course, it does come round only once in 76 years. It's been doing that for a long time, and this coming apparition certainly isn't the last we'll see of it. It'll come back again in the year 2061. But of course, the really bright comets have periods of hundreds or even thousands of years. We never know when to expect them, but we can promise you the Halley is right on course. Now let's come on to La Palma in the Canary Islands. And this is the new observatory that's been set up there. And it's very largely an outstation of the Royal Greenwich Observatory. And one of the first domes to be set up was that of the INT, or the Isaac Newton Telescope. Now, I went there about a year ago. You may remember we did a program about it. And this was a photograph I took then of the dome for the INT. Now, the Isaac Newton Telescope was the largest telescope ever built in the British Isles. It had a 98-inch mirror, and it used to be at Herstmonceux in Sussex. But of course, we can't pretend that our skies are suitable for astronomy. Frankly, they are not. There's too much rain and cloud and artificial light pollution. And so the very wise decision was made to take the INT over to La Palma. Well, that was the dome a year ago. There is the dome today. And you can see what a transformation has taken place. Also, the INT has been given a new mirror. And there's the mirror, in its case, arriving on the top of the mountain in La Palma. In fact, it's a larger mirror than the old one. The old one was 98 inches. This is just over 100 inches, and there are not very many telescopes in the world that are larger than that. And of course, it'll be used under excellent conditions. But it won't be the only telescope on La Palma. In fact, there are some there already. In particular, there's the dome of the 1 meter or 40-inch telescope. When I last went there and did a program about it, this was the scene of the 40-inch dome, and by now that dome is complete. And here you see it to the upper left of the picture, the INT dome down to the right. Other telescopes will follow. In particular, there's going to be the massive 180-inch William Herschel reflector, which will be one of the largest in the world. And a very interesting point, the largest telescopes on La Palma are going to be controlled automatically. So the observer won't have to be in the dome. He won't have to be even on the island. He'll be able to control the telescopes from Britain. And this long-range technique has already been tried out between Britain and Hawaii, and it works. Something that would have been absolutely out of the question only a few years ago. So great things are happening on La Palma, and of course, I'll keep you posted as to developments there. Now, a look ahead into 1983. No really interesting eclipses visible from here, I'm afraid. There is a small partial eclipse of the sun in December, but not really spectacular. Of the planets, Venus is going to be a bright object in the evening sky all through the early part of the year. And in the spring, the evening sky will also have Jupiter and Saturn. And Saturn now has resumed its normal beauty because the rings are opening out again and the small telescope will show them well. Mars, I'm afraid, not well on view during 1983. It only comes to opposition once every 2 years, and we won't see it really well again until 1984. But still, we have got 3 of the 4 really bright planets. And, of course, there are always plenty of stars. And, as always, the evening sky during winter is dominated by Orion the Hunter. I wonder how many times I've talked about Orion since we started these Sky at Night programs a quarter of a century ago. But you can't miss it. Look for it fairly high in the south, and there it is, with its starry belt and its 2 main stars, Betelgeuse in the upper left-hand corner and Rigel in the lower right. And quite obviously, those 2 stars are not alike. Rigel is pure white, and it's a very luminous supergiant. In fact, you would need 60,000 suns all put together to make one star as luminous as Rigel. Well, Betelgeuse isn't as powerful as that. It's only about 15,000 times the sun's luminosity. But to make up for that, it is extremely large. The diameter of Betelgeuse is something like 250 million miles. And that means that it could quite easily swallow up the entire path of the Earth around the sun. It's an old star at a fairly advanced stage in its evolution. And the sun will become a red giant one day, although not yet, I'm glad to say. And in any case, it will never become as large as Betelgeuse is now. Also, Betelgeuse is unstable, and it is variable in light. Sometimes it's nearly as brilliant as Rigel, never quite. At other times, it's no brighter than Aldebaran, the red star in Taurus, the bull, which you can find by following up the line of Orion's belt. And from Aldebaran, too, you can see the little V-shaped cluster of the Hyades, and beyond that, the open cluster of the Seven Sisters or Pleiades. Well, at the moment, Betelgeuse is more or less at its usual brilliancy, rather brighter than Aldebaran, considerably fainter than Rigel. But it really is variable. It swells and shrinks, and it changes its output as it does so. And there's another very interesting thing. Betelgeuse is the only star upon which we've so far been able to detect any surface detail. Remember, from Earth, a star appears as essentially a point of light. But Betelgeuse is the nearest of the really big red giants, and using a very complex technique known as speckle interferometry, this picture has been obtained. We've actually observed patches upon Betelgeuse. Well, I'm afraid I really can't go into speckle interferometry now. That would certainly need a complete program on its own, and Betelgeuse is the only star so far to which it has been applied. But remember, the stars are immensely distant. Even Betelgeuse, the nearest of the big red giants, is over 300 light years away and maybe a good deal more. And in the ordinary way, a star appears as a point. If you turn a telescope toward a star and it appears as a large, shimmering globe, you may be perfectly certain there's something wrong with your telescope. It's going to be badly focused. And if you sharpen the focus up, the star will appear smaller. And generally speaking, the smaller a star appears, the better you're seeing it. But of course, it will twinkle, and that is due to the Earth's atmosphere. And the supreme twinkler in the sky is undoubtedly Sirius, the dog star, which again you can find because it's in line with Orion's belt. In any case, you can't mistake it because it is so much brighter than any other star. And it's also rather low down as seen from here, and that's why it twinkles so obviously. Because, you see, twinkling has nothing whatever to do with the star itself. It has to do with the Earth's atmosphere. It's often said that a planet doesn't twinkle and a star does. That's not entirely true, because if a planet's low down, it will twinkle. But certainly a planet twinkles less, because a planet appears as a small disk in the sky, and the star is a point. But in any case, it has to do entirely with the Earth's atmosphere. If your star is low down, as Sirius usually is from here, then the light rays have to come to us through a thick layer of the Earth's atmosphere. And the atmosphere shakes the starlight around, so to speak, and causes the twinkling. If, on the other hand, the star is almost overhead, and Sirius never is from here, then the twinkling is very much less, because the star's light comes to us through a thinner layer of atmosphere. And you can see that effect if you look straight overhead in the evenings now, and there you will see the bright yellow star Capella in Aurigae, the charioteer. And, of course, that's not so bright as Sirius, about the same as Rigel, but you won't see it twinkle very strongly because it is so high. Lower down, it twinkles very much more. Also, close to Capella, there's something else very interesting that I talked about a few programs ago, and that is Epsilon Aurigae, which is one of a triangle of faint stars close to Capella, Epsilon, Eta, and the third one, Zeta. Now, Epsilon, as you may remember, is an eclipsing binary. Usually, it's rather brighter than Eta. every 27 years, some mysterious object, a companion of the star, passes in front of it and dims the light down, quite appreciably. Epsilon's always visible with the naked eye, but instead of being brighter than ether, it becomes fainter. And you can see that from the comparison of how it looked in 1982 and how it looks now. And in those two diagrams, Capella is to the upper left. You can see the three stars of the kids. In the left-hand picture, 1982, Epsilon at the apex is the brightest of the three. But now the eclipse has started, and at the present moment, Epsilon is quite definitely fainter than ether. There's no doubt about it at all. Well, just what is this mysterious thing that every 27 years passes in front of the bright star of Epsilon Aurigae, and it really is a bright star, at least 60,000 sun power? Well, the companion is something very mysterious. We don't really know quite what it is. There have been suggestions it's a very young star, still condensing out of interstellar material, and not yet hot enough to shine. Alternatively, it could be a kind of disk of gas. There were even suggestions it might be a black hole. And a more rational idea is that it's a small, hot, bluish star surrounded by an intense envelope of gas and dust. But we don't really know, and Epsilon Aurigae is unlike any other star we know. And at the moment, it's in the middle of its eclipse, and astronomers all over the world are paying very close attention to it. Because when this eclipse ends, nothing more will happen to Epsilon Aurigae for another 27 years. But of course, it is an eclipsing binary, not genuinely variable. If you want a true variable star, well, Betelgeuse is one. And there's another in the constellation of Gemini in the general area of Orion. It's called Tropos, and it varies by about a magnitude in a rough period around about 140 days. It's always rather fainter than its neighbor, the orange star Tejet, but it does vary quite perceptibly, and you can follow its fluctuations. In the same area, there's something worth looking at. This is the open cluster M35, Messier 35. You can just about see it with the naked eye on a clear night. Binoculars show it clearly, and telescopically, it really is a lovely sight. Although, of course, it's nothing like so conspicuous as the Seven Sisters or the Hyades in Taurus. There's a lovely old legend, by the way, associated with Gemini. In mythology, Castor and Pollux were twin boys. Pollux was immortal, Castor wasn't. When the inevitable happened, and Castor was killed, Pollux pleaded to be allowed to share his immortality with his brother, and this was granted, so both boys were placed in the sky, where you can now see them as two stars. And again, they are not alike, and neither are they genuinely associated in the sky. Remember, there are no 3D effects, and the stars in any particular constellation are not at the same distance from us. And it so happens that Castor is about 10 light years further away from us than Pollux is. And remember, 1 light year is equal to 6 million miles, so they're not true neighbors. Let me show you what I mean. Here we have Pollux, the orange star, and Castor, the white star, and they appear fairly close together. But they are not. This, in fact, is a model, and if we turn up the studio lights, you will see what I mean. Castor is in the background, so to speak, and this emphasizes yet again that what we normally call a constellation isn't really anything more than a chance alignment of stars at very different distances from us. And the stars in any particular constellation are not necessarily associated with each other, any more than Castor and Pollux are. And there's another way, too, in which those two stars are different. Pollux is a single star. Castor is not. If you use a telescope of reasonable power, a 3-inch refractor will do it, you will see that Castor is not single. It's made up of two stars, two components, one rather brighter than the other. And they're separated by something like 8,000 million miles. Now, if you use spectroscopes, it's possible to prove that both those Castors are again double. So we have two double stars, each moving around their own common center of gravity, rather like the two bells of a dumbbell do when you twist them by the joining bar, and also moving around the common center of gravity between them. And moving round those two stars is yet another binary, a third component of the system, known as YY Geminorum, made up of two faint red dwarfs. So really, Castor is a kind of family party, moving rather like this. Only do bear in mind that everything's tremendously speeded up, because the faint red pair takes something like 10,000 years to complete its journey around the two closer pairs near the middle. And I just wonder whether there's any planet anywhere near the system of Castor. If so, the sky must be truly incredible. Instead of one yellow sun, there would be 6 suns, 2 faint orange ones in the distance, and 4 brilliant white suns close at hand, each made up of 2 pairs. Whether there is any planet in the Castor system is something we obviously don't know, but I suppose there could be, and if so, well, their sky really beggars the imagination. There's one rather interesting fact about Castor and Pollux. The astronomers of 2,000 years ago all said that Castor was the brighter of the two. And at the present moment, that is certainly not the case, because Pollux is the brighter by about half a magnitude. So unless Castor has faded, or unless Pollux has brightened up, then the old astronomers were wrong, or there's been some mistake in interpretation or translation. I don't think it's very likely there has been any genuine change, because Castor and Pollux are not variable stars and show no indication of that. So I think probably the old astronomers were either wrong or have been misinterpreted. But it's interesting nonetheless, and it's not the only case. There are several other instances of stars which are now either considerably brighter or considerably fainter than the astronomers of 2,000 years ago said. Gemini, too, is an interesting constellation inasmuch as it's very rich. It's crossed by the Milky Way. And if you use binoculars or a wide-field telescope and look at the Milky Way, you will see countless stars. Of course, once again, we are dealing with a line of sight effect. Our galaxy is a flattened system. When we look along the main plane, we see many stars in almost the same direction, and that causes the Milky Way effect. But it's wonderful nonetheless, and Gemini is a very rich part of it. I'm afraid I've strayed some way from Orion, so let's come back to it now. There again we have Betelgeuse and Rigel. Look below the three stars of the belt, and there you will see M42, Messier 42, the best example of a gaseous nebula, the sword of Orion. You can see it quite clearly without a telescope. Binoculars show it well, and of course a telescope will show its form as well as some of the stars mixed in with it. Photograph it with a huge telescope, and that's the kind of results you get. But do bear in mind that although those colors are genuine, they are so faint and so fugitive that you can't see them simply by turning a telescope toward the Orion Nebula. The colors are too dim for that, just as you can't see colors by moonlight. But the Orion Nebula is rather more than 1,000 light years away, and it is a kind of stellar nursery. Inside it, fresh stars are being created from the interstellar matter. And we know that something like 5,000 million years ago, our star was born from a nebula in precisely that way. Of the other constellations now on view, there is, of course, the Great Bear or the Plough. That never sets over Britain, and on the opposite side of the pole star is the W of Cassiopeia, which also is permanently visible. It never goes below the horizon. So when the Great Bear is low down, Cassiopeia is high up, and vice versa. At the moment, you can also see the square of Pegasus, which is sinking in the west. And the Great Bear is visible in the north, still well above the horizon. And incidentally, if you look at the second star in the bear's tail, or the handle of the plough, if you like, Mizar, you will be able to see with the naked eye. There's a faint companion, which is Alcor, and telescopically, Mizar is itself double. And we have the same kind of situation as with Castor. Each component is again a double, so we have a quadruple system. There are plenty of examples of that in the sky. I said I'd give you the newsletter address. Here it is. Number 8 is now ready, so if you want it, send the stamped addressed envelope to newsletter number 8, The Sky at Night, BBC Television, London W12 8QT. But please don't put any personal letters inside, because those go to a different department, and they're the ones that are liable to go astray. So I think we can look forward to 1983 with great interest. We never know what's going to crop up, and I will do my best to keep you posted upon what's happening in astronomy. So for now, good night.